Hello and welcome. This is going to be our lecture video for September 11th. For this lecture, we're going to be focusing on this worksheet that was given in class. If you don't have a copy of this worksheet is also available on the extra stuff calendar. So hopefully you are watching this before our Google Hangout and going to bring questions to the Google Hangout if you have any. All right. Let's go ahead and get started here. Put your name, date, period on here. We start off with just some simplifying fractions. All right, I'll do number one. So in order to simplify a fraction, you need to look at what the top and the bottom are divisible by and see if there's anything in common. Now you could try to get the biggest number that they're both divisible by and do it in one step, or you could just go for the first number you can think of. Here, they're both even, so we know that dividing the top and the bottom by 2 is going to make them smaller. 54 divided by 2, that's going to be a 27. 144 divided by 2, that is a 72. All right, and now we check again. Is there some number that they're both divisible by? This time 2 won't work because the top is odd, but maybe 3 will work. Let's check our divisibility rules for 3. 2 plus 7 is 9, so that is divisible by 3. 7 plus 2 is 9, that's also divisible by 3. So I'm going to divide the top and the bottom by 3. All right. On the top, 27 divided by 3 is 9. 72 divided by 3, I believe that's 24. Yeah, 24. Let's check again. 2 still doesn't work. 3, can 3 work again? 9 and 24, yep, those are both divisible by 3. So divide the top and the bottom by 3, and now I've got 3 over 8. All right, 3 is prime, so we know that we're done. We can put a box around that. That's our simplified fraction. All right, you got 3 more for you to try there, but now we're going to move on to what happens when we also have some variables. So the first thing we want to do with these problems with variables is expand out any exponents. So problem 5, what I'm going to do is I'm going to rewrite this as 11 times x on the top, and then 2 times x times x times x 5 times on the bottom. All right, and I like to actually write out the multiplication too. All right, now if you have something the same on the top and the bottom, you can cross it out. So I can get rid of 1x. And then these 4 x's, they get put back together into an x to the 4th. So our final answer is 11 over 2x to the 4th. 1x canceled from the top and the bottom if you compare these two. Okay, let's look at maybe a problem like number 8. So I'm going to rewrite this as 2 times and then 6 x's on the top. That's what it would look like if we expanded x to the 6th. Over 2 times x times x times x. All right, and now we can start canceling x's. Cancel 1 from the top, 1 from the bottom. 1 from the top, 1 from the bottom. 1 from the top, 1 from the bottom. And then these 3 remaining x's will get put back together into an x to the 3rd. But there's more canceling that can happen here as well. The 2's can cancel. There's a 2 on top and a 2 on the bottom, so those cancel out. And the only thing that's left are those 3 x's, which we already put back together to be an x cubed. So final answer, x cubed. All right, let's look at problem number 9. So we've got 5 m's on the top, and 4 m's on the bottom. So 4 of those m's can cancel. So cancel, 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 cancel. And now right here with the numerical part, we're going to divide the top and the bottom by 2. So now we've got a 1m on the top over 2. We don't need to write that 1. We can just write it as m over 2, final answer. for problem number 9. Okay, let's look at one of these that has two variables. So variables can only cancel with similar variables. So let's look at 14. So on the top, when I expand that out, I've got 3 x's, so x times x times x, and 4 y's, so y times y times y times y, all over 6 times just a single x times 2 y's. So now as I go to cancel, an x can cancel with an x, but now I've got no x's left, so I'll put these two x's back together as an x squared. A y can cancel with a y, another y can cancel with another y, and then these two y's are left as a y squared. And now we can write our final answer, x squared, y squared, all over 6. All right, I think we'll call it good right there. Finish up the rest of these problems, bring questions to the Google Hangout. Have a good rest of your day.